Hey everyone, this is Shane Smillian, and I'm going to be giving you a lesson today on how to find the least common denominator. And it's a topic that most people, once you get far enough along in math, you can pretty much look at fractions often and find the least common denominator. But a lot of times people look at the fractions, they don't really know what they're doing in their head, but they're able to look at it and figure out the least common denominator. Or if there's a problem where there's just a bunch of fractions. A lot of times people will just multiply everything together and just make that the denominator, but that's not really the least common denominator. So I'm just going to do a little review here on this topic, and we're going to start out by talking on the subject of factor trees. Basically, I'm going to talk about how to make a prime factor tree, and we're going to start with that first. When you have a number, let me just give you a number here. Let me give you two numbers. Do something pretty simple here. We'll start out with the numbers 10 and 20, like this. And let's say that I want to find out what is the least common denominator between 10 and 20. And I think most people, if they saw a fraction, they would probably be able to look at that and say, well, the least common denominator is 20, right? But let's just start examining why is that true. It is 20. But let's just examine, why is that even true? Like, what's going on with that to make that true? Well, the first thing I want to do is I want to start out by doing a prime factor tree. And the first thing that we do in a prime factor tree is we make these two branches to show the two factors. Now, I always start with the lowest factor first, the lowest prime factor first, okay? So the lowest prime factor that we can think of here is going to be 2, and this is going to give us 5, like this. Okay, so that's 2 and 5. Let's take a look at 20. Okay, here's 20. Now, what I don't want to see you do when you're doing these factor trees is I don't want to see people writing like starting with a high prime factor like 5 and 4. Okay, I don't want to see that. It's bad practice. Or I don't want to see someone starting with just something like 4 and 5. Because those may be the first factors that come to your mind. That's bad practice. Okay, let's not be breaking out factors that are not prime. If you're going to go through the trouble to make a factor tree, make sure they're all prime. Number one. Number two. I mean, eventually they will become prime, but I want it to be a systematic process when you do this. I don't want it to look like spaghetti. Okay, and what I mean by that is let's start with the lowest prime factor here is 2. We always start with 2. If 2 doesn't work, we go to 3. If 3 doesn't work, we go to 5. If 5 doesn't work, we go to 7. So I'm going to have 2 and 10 here. Okay? So then I'm going to break that down even further, and I keep going with the lowest prime factor. In this case, it's 2 again. I can use a 2, right? And then I'm at 5. Now I'm done. Okay, so if I took this line here, I'm going to draw a line. These are the prime factors down here. You see all these below here? These are all the prime factors. These are all the prime factors here. Okay? I'm just going to draw a line like this. Okay? So that's how a factor tree should look. A prime factor tree always start with the smallest prime factor and you just keep going up. What would it look like if you didn't? Well, it might look something like this. I'm going to draw in red just to show you this is not the way I want you to do it. Let's say that you did something like, you could do 5 and 4. I don't really like that because then you're going to break that into something like this. Okay, and then they're going to kind of be out of order. And when you get into much larger numbers, it can be it almost looks dyslexic. It almost looks like spaghetti mess when you start doing it out of order like that. So we want to stay away from that. Okay, when you get into bigger numbers, it becomes a huge mess. So always start with the lowest prime factor, which is 2. So what's prime factors? A number that's divisible by itself in 1. So the prime factors that we're just basically going to be looking at on these trees. The prime factors that we're going to be looking at primarily are going to be 2, 3, 5, 7, primarily. We'll just basically stick with those. I mean, we could get into larger numbers, right? We could get into like 11 if we wanted to, and we might get into 13. Hopefully that's staying on the screen for you. But really, I mean, beyond that, it's possible that you could have some further out, beyond that, like 17 or something. But these are going to be the basic numbers you're going to be working with. And I always want you to go in that order, okay? So let's keep it in that order. as we're doing these factor trees. I'm going to pull this over a little bit here so it's back in the picture. All right. Okay, so here's our prime factor tree. So now, how did I know that the least common denominator was 20? A lot of people can look at that and say, oh, it's 20. No problem, right? Well, here's how you know. Here's how you do this. What I'm going to do is first I'm going to look at numbers that they have in common first. What do they have in common? Okay, so they have a 2 in common, and I'm going to circle that here for a reason. There's a 2 here, and they have a 2 in common here, right? Okay. So what I'm going to do is I'm going to write that number down here, the number 2, put a circle around it, because that means they shared it, they had it in common. And when we're talking about common denominators, it only has to be common twice. In other words, if I had 3 or 4 numbers up here, it only has to be common twice to come out once. So I'm going to cross that out. Okay, here's my prime factor tree. This is the only thing that matters. Okay. Now, next thing, what else does it? Let's go up to the next prime factor. Are there any more 2's in common? No. Let's look at the 5's. Is there a 5 in common here? There sure is, right here, right? They're in common. Okay, so I circled that. I'm going to write this here. 5. I'm going to cross that out, just like that. Now, what's left? There's nothing left in common, right? So I'm going to put a little multipliers there. So what's left over? Well, the only thing left is the 2, right? So my least common denominator here is 2 times 5 times 2, which is 20. Okay, so that's my least common. Well, if we were talking fractions, we would say least common denominator. In this case, it's the least common multiple. It's the same thing. If we were talking about a fraction, if this was, 1 over 10 or 1 over 20, I would be saying least common denominator. Same thing. It's the least common multiple that we have down there. Okay, so let me just go down here. Let's do another example. So hopefully you can understand that. Let's just review for a second here. So my least common multiple of this, okay, I made my factor trees, okay, and I found my prime factors, and I found the common prime factors, and I took them out. Each time they had something in common, I struck it, I circled it to show it was common, I crossed it out. I looked for the 5, crossed it, took it out once. Whatever's left over is there. That's my least common denominator if I was looking at these two fractions. So if I was, let's say that I was adding these two fractions, let's say I had 1 over 10 and 1 over 20, then I know that in this case, if I have 1 over 10 plus 1 over 20, that my least common denominator would be 20. So this would be the same as saying 2 over 20 plus 1 over 20, right? And so we're going to get 3 over 20. Now, just remember, adding and subtracting fractions are much harder than multiplying fractions, right? So that's why we have to find the least common denominator if we were working with fractions. But again, this is interchangeable with the least common multiple. But usually, when we do this, we're talking about fractions. Usually, that's the case. So let's do some more interesting numbers here. Let me see if I can scroll down a little bit. So let's say that I gave you the numbers 5, 10, 15, and 25. Okay. So how would I start finding the least? How would I find the least common multiple of these numbers? Well, we're going to start with 5, and since 5 is prime, I'm just going to have a 1 and a 5. Okay. Let's start with 10. Well, what's the first prime factor we can use? The lowest prime factor, 2 and 5. Okay, and we're done. Let's look at 15, 3 and 5. Let's look at 25, 5 and 5. Okay, so there's all your factors. There's all your prime factors. And again, these are pretty short numbers, but those are my prime factors there. I didn't even have to really go down much. But let's start pulling these numbers out. Okay, so let's look at a 2. Is there a 2 in common with anything? No, there is not. Is there a 3 in common with anything? No, there is not. There's not a 3 in common, right? So what's in common? What's the first thing that we have in common? We have a 5 for sure, right? So look at this. This 5 is in common with this. With all of them, they all have a 5 in common, right? So I'm going to take that out once. So I'm going to put here least common multiple. Okay. First thing I take out is a 5. Put a circle around it. Okay, cross that out like this. Is there anything else in common? You see anything else there? No, there is not. So what's left over? I've got a 2, I've got a 3, I've got a 5. Okay, so 2, 3, 5. So again, what is my least common multiple here? Well, 5 times 2 is 10. 10 times 3 is 30. 30 times 5 is 150. So there's my least common multiple of 5, 10, 15, and 25. So when you get into fractions like this, it's very important to understand how to find the least common multiple. All right, let's do another example here. So this is going to be the third example that I'm going to do. Okay, let's start here. Let's do a few more numbers together here. The least common multiple of 6, 9, 15, 50, and 100. I'm going to add a few more. And the 100 is the perfect example here of why I want you to focus on the primes first, because I'm going to show you if we did 10 and 10 first like this, then we did 2 and 5 and 2 and 5, or 5 and 2. If we don't go in any particular order, it starts to look very confusing there, right? So this is why I always want to start with the prime factors in the correct order. So start with those smallest prime factors first before we start making these factor trees, because these are supposed to be prime factor trees. So here we go. So 6 is going to be 2 and 3. 9 is going to be 3 and 3. 15 is going to be 3 and 5. 50 is going to be 2 and 25. And then the lowest prime number at this point is 5 and 5. If I have 100, I'm going 2 and 50, right? I'm going 2 and 25. And now I'm going 5 and 5. Okay, so let's look at our prime factors here. I've got 2 and 3 here, 3 and 3 here, 3 and 5 here, 2, 5, and 5 here, and then my prime factors are 2, 2, 5, and 5. So let's just focus on our prime factors down here. That's all we need to do. This is not that difficult. Okay, so let's look at the numbers we have in common. Is there a 2 in common? Yes, I have one here. I have one here. And I have one here. Okay, so that comes out once down here. So let me just write it 2. Like that. Cross it out. Are there any more 2's in common? Nope. Let's look at a 3. Do I have a 3 in common? I do, right? I got one here. I got one here. I got one here. Take them out. 3 down there. Put a little multiply here. When again, we're finding the least common multiple. Okay. Cross it. Cross it. Cross it. All right. No more 3's in common, right? Is there a 5 in common? Absolutely. 5, 5, 5. Look at that. Beautiful, right? Here's another 5 there. Cross that out. Let me erase this little streak that appeared here. Okay, and let's cross out those other 5's just to show that we took them out. Now, do we have any more 5's in common? Yes, we sure do. And remember, they only have to be in common with 2 or more. They don't have to be in common with all of them, right? So let me just pull this out here. So now, just to show that it's a different one that we pulled out, I'm going to make it a different shape, just to kind of emphasize that. I'm going to make it a triangle. Okay, so times the 5 with the triangle, right? And that's just showing you that that was just from a different series that I pulled out. Okay, so what's left? Well, I have a 2, and I have a 3. That's left. Okay, so now I'm ready to calculate the least common multiple, right? So I'm just going to multiply everything together, and we're going to find out what it is. So I have 6. 2 times 3 is 6. 6 times 5 is 30. 30 times 5 is what? 150. 150 times 2 is 300. 300 times 3 is 900. So the least common multiple of all of these numbers is 900. And that's how you would find it with more numbers. Okay, so now let's do something interesting. Let's find a least common multiple of of variables, right? What if we had some crazy variables like this? Let's say I had x and y, okay, like this. And let's say that I had x squared and y, and then I had x and y squared. And then let's say that I have x to the fifth, y to the third. And I want to find the least common multiple of all of these. So how would I do that? Well, that's kind of more like an SAT type of an application, like an SAT problem. Sometimes they'll ask you that, but okay, let's do it. It's not any different than what we just did. How would I find the least common multiple of that? It's the same thing. You just make a factor tree. And we're going to assume that these factors are just prime. So we have x and y in this case. I'm going to start with x. So I'm going to say x times xy. And then I'm going to go down here and I'm going to say x and y. Here I'm going to say x. And then I'm going to say y squared. And then I'm going to go down here and I'm going to say y and y. And this one's going to take a little longer to do, but we'll do it. So I'm going to say x and x to the fourth, y to the third. Come on, right in there. Y to the third. I'm going to say x to x and then x to the third, y to the third. It's going to take a while. Whew. X squared, y to the third, x, y to the third. So it's going to take a long time. Let me scroll down a little bit so you can keep seeing this. Try not to go off the edge of the paper here. X, y to the third, y squared. Wow, it's taking a while. Y and y. Here we go. Well, that's a long prime factor tree, right? Okay, so let's just double check here. Let me draw my red line just to show my prime factors. There are all my prime factors here. Here are all my prime factors there, right? X squared, so x times x is y, x times y. This one should give me x times y squared, which it does. And this one, I should have 5 x's down here as I keep going down this factor tree, this long factor tree down here. Let me keep scrolling down. Ooh, that thing's a huge tree. And then I should have the 3 y's, which I do. Let me see if I can zoom out a little bit here. Wow, this is, let's go to 150. Okay, you can see a little bit better. All right, so now that you can see everything, let's go ahead and do what we've been doing before, okay? So I'm going to do this in a little different color so you can see it. So let's start taking out, let's see if there's an x that comes out. Here's an x here, here's an x here, here's an x here, and of course there's plenty of x's over here, right? We have tons of x's to share. So here's my first x, circle, cross it out as such. Next one, let's look for another x that's in common. Well, this has one. Remember, we're going to change the shape here. Let's say I use a box this time. Here's another box here. So here's my x with a little box there. Take it out. Are there any more x's that they have in common? Nope. So let's look at y's. Here's a y that's in common here, 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 and here. Take it out once with the circle. One, like this, like this, like this. Is there another y that's in common? Right here. Right here. Take it out once. Cross it out like that. And now what's left? Are there anything left that's shared? No, we look at all our prime factors. They're all crossed out over here. The only thing that's left here is this here, which is x to the third. That's left over. Right, I have x times x times x, and I just have a y here. Okay, so how many x's do I have if I'm finding my least common multiple here? I have x, x, x to the third. Now these are all x to the 1. So common base, when you're multiplying, you add the exponents. So that's x to the 5th. Common base with the y's, 1, 2, 3, y to the 3rd. So that's your least common multiple of these numbers in here. So that I thought that was kind of interesting. Talking about something that I've observed that I've called the chain rule for the least common multiple. And simply what it means is this. If you can get between these factors, okay, if you can hop between them with something that is a let's just say an integer factor that's not a decimal, then the least common denominator will be the last number. For example, if you looked at 2 and 4, what's the least common denominator of 2 and 4? The least common denominator of 2 and 4 is 4, because you can get there by multiplying, right? Okay. But if I added something like a 9, I can't get from 4 to 9 just by multiplying across, right? So in that case, I would have to make my factor tree to find out. But if I was just interested in the 2 and the 4, then my least common multiple is just 4, right? And then if I gave you another number like a 12, right? So if I can hop from there from 4 to 12, and I can go times 3, now my least common multiple is 12, because I'm going to keep, it's a chain rule. I'm going down the chain like this, right? And let's say that I gave you another number that was 48, right? So I can hop from here to here and just multiply that by 4. So right away, my least common multiple is 48. So I mean, we can do it the long way. I mean, I can prove it to you. But again, if you can hop from factor to factor and link them with an integer factor, in other words, you don't have to multiply them by 2.2 or 2, something like that. You can link them like this. It's always going to be the last number. And that's a pretty cool thing to look at, because if you have some fractions, let's say you had like 1/2 plus 1/4 plus 1/4, come on, writing pad, plus 1/12. Writing pad is not behaving. 1/12 plus 1/48, right? And you wanted to find the least common denominator. Least common denominator is going to be just 48. So let me just prove that to you, and we'll finish out this video shortly after that. Okay, so let's go to 2. So 2, I just have 1 and 2. If I have a 4, my factors are going to be what? My factors are going to be 2 and 2. If I have 12, my factors are going to be 2 and 6, 2 and 3. If I have 48, it's going to be 2 and 24. It's going to be 2 and 12. It's going to be 2 and 6, as such. Okay, so let's start taking these out. 2 here, 2 here, 2 here, 2 here, right? And again, my prime factors are here. Just to clarify again, these are my primes that we're looking at. These are my prime factors down here. Okay, those are my primes. So the 2 comes out. Here's your 2. Like this. Here's a 2 here. Here and here. That comes out. Okay. Cancel that out. Okay, what else is left? Well, there's a 3 and there's a 3, right? So here's my 3. Here's my 3. Here's my 3. Cancel that out. Cancel that out. What am I left with? Well, I'm left with the 2's here. Times 2 times 2. Okay. So what does that multiply out to be? Well, I have 2 times 2 is 4. 4 times 3 is 12. 12 times 2 is 24. And 24 times 2 is 48. So that is the least common multiple of those numbers. But you don't have to even calculate them if you can hop along here. And when we started out this presentation, we were talking about, how would you know if sometimes you'll see two numbers, like for example 1/10 and 1/20. How would you know that the least common denominator is 20? Because instinctively you knew in your head that you can just get there by a factor, and using this chain rule you can determine what that is. So I'm Shane Smolian. Thanks for watching. That's all I got for you right now. Check back for some more videos on different topics, and be sure to write in if you want a video on a certain topic. I'll be more than happy to post it. I'll talk to you soon.